So claims like this one
Although philosophers may have a way of asking profound questions about truth or reality or cause, they just isn't helpful to the work of a scientist. And historically, I think it never has been helpful.
In the ordinary language sense of the word fact, evolution is a fact.
Those claims have led me to investigate how science relates to reality holistically. Is science the only way to actually understand reality? How certain is science when it comes to different disciplines and all these other questions? So in this video, we're going to discuss things about the philosophy of science. Examples include the difference between observation and interpretation. We're also going to discuss how science relates to different theoretical and practical points. Then finally, we're going to define what complex systems are, and then we're going to relate them to the idea of the philosophy of science. So I think before we actually move on to discuss any topic, it's pretty important to actually define what science is.
I'm going to discuss how we would look for a new law. In general, we look for a new law by the following process. First, we guess it. Then we well, don't laugh, that's really true. Then we compute the consequences of the guess to see what, if this is right, if this law that we guessed is right, we see what it would imply, and then we compare those computation results to nature, or we say compare to experiment or experience. If it disagrees with experiment, it's wrong.
So science is usually described as a way to approach the world, or the physical world to be specific, that includes conjecture making, which is just seeing things and then coming up with explanations from our minds, for example. And then we test those explanations or hypotheses, and then those hypotheses are tested by other people, which is another thing that is very underrated when it comes to the definition of science, because a lot of philosophers of science have actually defined science as strictly a social type of approach, because you have to quote unquote challenge your ideas, if that makes sense. So as we define science now, we see that the idea of science is a pretty broad category, let's say, of things, because it's actually coming to understand the physical world in and of itself. So in order for us to approach this broad category, I think it's good to actually categorize the nature of evidences. So the distinction is actually the difference between the observation and interpretation in science. So as we said, science is a way to understand the physical world, and the physical world has different mechanisms to understand it. So we have observation, which are things we can actually see with our own eyes, or by extension, we can see them with the use of advancements in technologies. So a good example of this is if we take a blood sample from a human and we put it under a microscope, we can actually see the blood cells that are present. So that is considered an observation because we can still see it as an observation. Another good example of observation is the roundness of the Earth, for example. So we can, using satellites and all these different technologies, we can actually see that the world is round. So that's an observation rather than an interpretation. So the other nature of evidence that we have in the context of today's video is interpretations. So the idea of interpretations is when we see different data points and we make inferences about those data points, or we make logical structures about those data points. So it's not something we can necessarily see or observe, but we make logical inferences about those data points. So a good example of this is something in evolutionary theory called homology. And what homology stipulates is that because different living things are similar in structure and function and physiology, therefore they have a common ancestor. So that's an interpretatory scope. It's not an observatory scope. Although it might have different levels of evidences towards it, but it's fundamentally an interpretorial type of approach. So now we come to the importance of this distinction between the interpretation and the observation. And I think the importance goes back to one point I made earlier in this video, which is that this can give us a more of a holistic approach towards science and reality in general. Because as soon as we understand that there's different natures of evidences, we can understand that within science, different probabilities weigh into those different natures of evidences. So for example, as soon as I understand that something is an observation, then that has much more epistemic or probabilistic weight. It has a much less probability to be blown apart in the future, as opposed to interpretations which have different levels of assumptions above them, and that makes them much more prone to be disproven by future scientific endeavor, if that makes sense. So once we understand this distinction, we can understand that there are different probabilities that weigh into different natures of evidences, specifically the two we've mentioned. Now, I want to take some time to actually speak about the relevance of this distinction, because I don't think it's universally relevant to everyone, if that makes sense, because I think the scientists who actually work in the laboratories and are actually engaging within science already have an innate understanding of this principle, I believe. So I think it's not very much a practical distinction, but it's very much a theoretical or relating to truth type of distinction, if that makes sense. So I don't believe it's universally applicable to everything or it's practically applicable to science, but I think it becomes much more relevant when it comes to a person who's actually trying to understand the nature of truth and all these other things. One of the reasons why I actually wanted to talk about this is because I see that there is much more of a certainty approach towards science in general without making those nuanced distinctions, if that makes sense. And that is at least from my observation. Now, I'm not saying this is applicable to scientists per se, but I'm saying this is from my experience when it comes to people in general. So this brings us to the last point I wanted to mention, which is the idea of linking the complex systems to the philosophy of science. Now, the relationship is not very much a direct one, at least in my conceptualization. The idea of complex systems is when the whole is more than the parts. So you have different parts coming up together and they give rise to a whole new whole. So for example, you have different nerves coming up together and then somehow they give rise to the human consciousness as complex as it is. So that's the definition of a complex system. Now, how does that relate to the philosophy of science? I think when we understand that complex systems exist abundantly in the world, we can approach science and all the distinctions we've made previously with much more humility in general. It might seem like we really understand everything around us because of the way we came to control the environment with different technologies. So we have computers, we can use satellites and all these things. So all these things that help us control the environment around us might make us think that we understand everything. But as soon as we look into the other side of things and try to see the complex systems around us in the world, we can have much more humility towards the scientific endeavor in general, and anything else for that matter. So with that, we conclude our video for today. If you reach this point, thank you very much for watching. I'll attach the blog post I've written about the philosophy of science, which is related to the topics we discussed today, but in much more detail. So I'll attach the blog post's link to the description and see you next time.